Hello everyone, this is Ari from Pantech. So in this previous session, we have developed this function for activating this pump and sprinklers, right? So today what we are going to do is we are going to get into the concept of watchdog timers. So we will take a scenario of we are connecting this, controlling this pump and sprinklers. So we are reading this sensors very continuously. So we have to, the process is going to be run continuously, right? So we have to monitor it, right? If it is working correctly or if it is the readings are correct, if the loops are getting executed in a correct manner. So we have to know all these things. So if there is some problem, we have to reset the controller from. We have to start this controller from the beginning or reset. Okay. So the user we have to define we have to develop the code based on the user's experience. Okay. So users should not users should not reset this controller. So the controller should be understand study itself and it have to reset itself. So we have to, so for that purpose only we are getting into this watchdog timer concept. So the name itself describes this. It is like a watchdog. So it is going to watch our loops and all our codes running processes. And if there are some errors, means there will be a interrupt generated in this watchdog timer, and it is going to reset our microcontroller. Okay. So this is for. So what is the main use of this? Is we will see it in our next slide. So before this, guys, we will. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be very much useful for you. So you can you have to, when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So so don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like this. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a code. And even the concept is you are not clear with the concept, means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can, in this internship, we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I am giving a presentation, right, for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the core concepts and communication protocols. All those files also will be included in this 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So that will be exclusively available for these internship students. So you can you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefits? Is we will have a one-to-one live sessions. So what is this? Is you can interact with me for 1 hour every Saturday class. So you can ask the doubts. You can clear the doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM32, right? If you have a doubts related to the other microcontrollers, or you are doing lots of or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller, means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to, you can also prefer me to do and take some new topics some topics some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic, not based on STM. If you can ask, if you want other topic more than out of this team, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on ARM M4, which is an industrial based controller in a register level, right? We are not using a advanced library, all libraries or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is in a from 0 to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in register level. So this certificate will be very much useful for you. So what are the 2 certificates we are going to give? We are going to give 2 certificates. One is for participation and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC 1 coupon code so that you can get this 509 discount. And the discount fees is 691. Okay. So you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, or you can see this description box. In the description box, there's a registration link will be available. So join as an internship user and use this internship as a upskilling opportunity for you. Okay. So we will get into the concept. We are going to see this. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial intelligence, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this link, and link will be provided in the description box and as well as chat box, or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students, what is the technology they have the industry required. So what is the technology that the industry needed. So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So we are the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students. So those technologies going to be teacher you going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to give you offer you we are going to make you placed in this your dream companies. Okay, so guys, don't miss this opportunity. So you can enroll in this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll. Who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. 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 Now we will see why we are going with washout timer. So we can use this washout timer to detect the software faults, and this is a counter which is going to count from maximum to minimum. So it is a down counter. Then it is going to reset the system when there is a error in the system, and there is some error in the code, and if the code is not executed, then it is going to reset the controller automatically. And it is also used to detect the abnormal or earlier application behaviors. So these are the things we can use. These are the reasons why we are using this watchdog timers. Okay. So once it is activated, we can't disable it. We have to we have to refresh the watchdog timer only. So we can't disable this thing. Okay. So what is the next thing is in our STM32 we have two timers. One is a window watchdog timer and another one is an independent watchdog timer. Okay. So for this we will see it now. I will open my CubeMX. So wait, it is loading. Okay. So you will go to this clock. So you can see our independent watchdog timer is directly connected to this LSI, which is a crystal of the internal clock of frequency of 32 kilohertz. So it is going to independent watchdog timer is going to run without the help of this CPU. So even this clock frequency in the CPU, the main clock is disturbed, means this watchdog timer will not get disturbed. So it is going to run on its own clock pulse and oscillator. So what is the frequency is 32 kilohertz. Okay. So this is what independent watchdog timer is. Okay. So then the Windows watchdog timer will be connected with the peak clock of 1, which will be connected with this APB 1 bus. Okay. So this is a Windows watchdog timer, and this is the independent watchdog timer. So what is the differences? So if the system is get error, or if this clock is system clock is at some errors, means the Windows watchdog timer will be affected. But when we use this independent watchdog timer, means it will not get affected, and we can reset the total. We can reinitialize the total system, so that we can make the give the solutions for the we can reinitialize this clocks of the main CPU. Then it will be removes the bugs. So this is how the watchdog timer works. Okay. So we will see this in depth. Okay. So you can see. So there will be two scenarios. Both the controller and the watchdog timer will be running in the same clock, or it will be running in the different clocks. Okay. So we will see what is the working process. So what is this going to do is the controller will be controlled with the clock, and the watchdog timer also will be controlled with the clock. So the controller will execute all the lines of program which we have coded into it. So it will execute all the codes, and at a particular of time which we have a specified time, it is going to reset the watchdog timer. Okay, at the specified time of loop. So every time, all the time when the system is controller is running, it is going to reset this watchdog timer. So we will take a scenario that now my loop is stuck at some of the place, okay, some position. So now it didn't reset this watchdog timer. What it happens is now the timeout. What is the timeout means? What is the time we will be given that. So what is our reload value? So timeout will be our reload value. So which is giving in our reload value register. So when it reaches the reload value, we have to reset the watchdog timer before it reaching the reload value. If the controller does not if the controller is stuck in some loop and does not reset this watchdog timer, means what the watchdog timer is going to do is when it resets timeout, it is going to reset this old microcontroller. So it will sense a signal and it will reset the controller system from, and it will controller will starts from beginning of the stage. So this is why the watchdog timer is an important concept. So in all the appliances we can see there will be a watchdog timers. Okay. So this is the process. So while creating our project for smart agriculture. So while we will take a scenario if my pump is not running. So that time I have to reset the controller, right? So the user can't go to the form and reset it. So the controller should understand the loop and it should reset it itself. Okay, automatically. So for that purpose only we are implementing this watchdog timer to the controller. Okay. So what is the next thing is so what are the steps we have to do for independent watchdog timer setup configuration? So first we have to start this watchdog and we will have an access key because the prescale value, prescale register and reload register will be protected. So we have to give this access. So access key to it. So we will access key will be provided in this data sheets. Okay. So then we have to set this prescale value and reload value, and we have to wait till this values are get updated in the registers. Then we have to disable this access and we have to reload this watchdog timer. Then it will start to run. It's going to down count from what is the reload value we are given till to 0. When it reaches a 0, it's going to reset the microcontroller. So before it reaching the 0, if we refresh the watchdog timer, means it is not going to reset the controller. Okay. So this is how it is going to work. So we will implement those things in the code which we have developed yesterday. Okay. Okay. Now we will get into a code which we have developed yesterday for our pump. Okay. So this is a code which we have developed yesterday, right? So for operating the pump and sprinklers. So this is our condition. So we have to check this. We have to run this loop continuously, right? If there is some error in this position of 106 means the loop will be stopped here. So to rectify this error, we have to reset this controller. So for that purpose only, we will implement this watchdog timer and we will reset this watchdog timer here. Okay. So we will create this code first. So what are the things you have to do is first you have to tune on this LSI clock, okay, oscillator. So go to this GPA of init, so which we have defined already. So we have this here, right? So what is the first thing you have to do is we have to tune on this LSI internal clock low crystal. It will be operating in the low voltage. Okay. So we have this LSI state. So we have to tune on this. Okay. CC off. This will tune only LSI. LSI on. Now we have tune on this LSI. Okay. So what is the next thing we have to do is we have to add this LSI here oscillator type. CC off. Oscillator type is like this LSI. Okay. So these two things we have to declare in this. We have to update in this GPA unit. Okay. So next we will get into this main function. So what are the function we are going to create is we are going to create a watchdog primary init and refresh. Okay. So I will do it static. Static of void. This I'm going to interest independent watchdog timer. So we will see this independent watchdog timer. So we are going to configure this independent watchdog timer only. So it will act independently without the help of this system clock. So that is what we needed. So we didn't need to use this system clock. We have to use the watchdog timer's clock as an external. So which will operates even the absence of system clock. Okay. So so this is the first function we are going to create, and we are going to create this refresh function. So these two functions we are going to create. So we will make it. Okay. So what is the first thing we have to do? So before that, we have to get into this data sheets. Okay. So we have this in the reference manual. So go to this. So we have first have a key register. So this is a register used for starting a watchdog, reloading the watchdog, giving the access key, providing the access key. Lot of things we will provide in this key register. So what is the first thing you have to do is you can see here. So for writing the key values, you have to give this 4 C's to start a watchdog. So first we have to tune on this watchdog. Okay. First we will tune on this watchdog. Okay. So we have this. So register of cross off. So this will start my watchdog process, right? So what is the next thing you have to do is we have to give the access key. So you can see in refer to this reference manual. You can see we have writing the key value of 4 5 enable the access to prescaler register and reload register. Okay, so we have to provide this access key first. So it will be this so this is the access key for our watchdog. Okay, so what is the next thing you have to do is we have to set this prescaler value. So PR off. So what is the prescaler value we are going to set this? I will. So for setting a prescale value, we have the formula. So I will show that formula. So you can see this formula. So see this formula here. So what is our time period I need is now take the scenario of we need a time period of 20 milliseconds. Okay. So I have to start from 0 to, I have to start the reload value from 20 milliseconds to 0. So when it reaches 0, it is going to reset my controller. So before reaching 0, I refresh the watchdog time limits. It is not going to reset my controller. So this is the process. So I need is 20 milliseconds. Okay. So what I have to do is we have the formula for reload is equal to. So what is the time we needed and what is our frequency? So our frequency is 32 kilohertz. So it means 32,000. So next is what is our prescale value? So we will go to it. So you can see we have this prescale divider. So we can give this any of these values 4 to 256. So what is the first value I'm going to use this? I'm going to use this 8. Okay. So I'm going to do this prescale as an 8 and we have to multiply it with 1000 and finally you have to subtract it by 1. So what is the final value you will get this? You can see 20 into 32,000. So divided by 8 into 1000. So we will get us a 79. Okay. So if take a second scenario, we need a 10 seconds. So the reload value should start from 10 and it should reset the controller at the 0th second. So it is the time period is 10 seconds. So for that, what I have to do? I have to give this formulas based on milliseconds, right? So I have to give it in milliseconds. So 10 seconds means the 10 seconds is equal to 10,000 milliseconds, right? So I have to multiply it with this 32,000 kilohertz. And what is the prescale I am going to use this 256. So higher time, so means we have to higher the prescaler. So I am going to use this 56. So what is the final value you will get is 1249. Okay. So first scenario, you will use this prescaler value and reload value. In second scenario, you will use this. This is for testing our watchdog timer, and this is for our pump. This is for our watchdog. Okay. So what is the prescale value we have to set at first? So what is the first value is we have to set the prescale value as 8, right? So go to this and check. So you have to send this logic 1 to the 0th bit. So I will send this 1 to the 0. So it is going to set my prescaler value. So what is the next thing we have to do is we have to see this status register. Okay. So we have this status register here. So the 0th bit is get set when this it is sorry 0th bit is get resetted when this prescale value is updated in the register. Okay. So this first bit is get resetted when this reload value is updated in the reload value register. So you can see here. This is the reload value register. Okay, so we have to first wait till this prescale value is updated in the prescale value register. So go to this and create the void. On left shift of 0. So because we have this prescaler update in the 0th position. So we have to wait till this bit is get reset. Okay. So then you have to you have to do this process again. So what is the next thing we have to do is we have enabled the access to it, right? So now we have to disable the access for it. So for disabling access, we have to do this 0 to it, 0 cross off. So this will disable the access. So for next we have to upload this reload value, right? So for that we have to again we have to enable the access and we have to go to this reload register. This is our reload register. So WDT. In this, what is the value we have to give us 79, right? Because we are going to calculate the time as 20 milliseconds. So it is 79. Next, we have to wait till this values are get updated in the reload register. So okay. Yeah. One. So now we will wait till this bit is get reload values get set in the reload register. Then we have to disable this access. Okay. To avoid some values, garbage values get uploaded in this values. Okay. So what is the final step we have to do? We have to reload the watchdog, right? So for that we have this. So this will refresh my watchdog timer. So now we have created the watchdog timer init function. So what is the next function we have to do is right. So next is refresh, right? Refresh function. So we have this refresh function. We have to just simply we have to do this 0 cross of 4 years. So this will reload our watchdog timer. Okay. So now we have created these both the functions. So what is the next thing we are going to do is we are going to add the GPIO pin to it because we are going to see this output in the LEDs. Okay. So we have to add some GPIO inputs as outputs. Okay. So what this port I am going to use is D port because we have this inbuilt LED in the D port. Okay. Next we will copy this all. Sorry, we should not do it here. Wait. Where is this GPIO? So what we are going to do is we will add this GPIO in this port itself. Okay, call this function here itself. So what are the things we are going to do is we are going to configure this PD of 14. So which is connected to our red LED, right? So we will make this copy of it. Okay. So what is the first thing you have to do is we have to define this pin. So we have this function GPA of pin of 14. So this is a pin I'm going to use, and it is output push pull. It can be same, and no pull. The speed is medium. Okay, no problem. So next is we have to give this port here, right? So GPA of P. So this will define my pin. Okay. Now we have defined this GPA pin. So what is the next step we have to do is we will get into this main. So we are going to check whether this watchdog timer is working or not. So the GPU is initialized. So after this GPU initialization, we are going to create all of relay, HAL of relay. In this, I am going to do a 500 milliseconds of relay. Then I am going to call this function write. In this, what is port GPU D and GPU. So in this, I am going to tune on this LED. Okay. Then I am going to call this init function of watchdog. Okay. So what it is going to do is when the my controller starts from the initial stage, it is going to get into this main loop and call these all the functions, and it is going to tune on my like LED. Okay, in this PD pin, PD 14th pin. Okay, then we will initialize this watchdog timer. What is the function we are going to do is we have to we have to reset the watchdog timer before the timeout. So which is what is our timeout? So our timeout will be 0 seconds. Before it reaching to 0, we have to reset the watchdog timer, right? So we didn't reset the watchdog timer means it is going to reset the old microcontroller and it is going to reinitialize the microcontroller from the starting state. So from if we are resetter the watchdog timer before reaching the timeout means what it is going to happen is this LED will be tuned on, it will not get tuned off. If I reset this watchdog timer more than this timeout means, so what is our timeout? It is 18 milliseconds. So sorry, 20 milliseconds, right? So if I reset this watchdog timer within this 20 milliseconds means the LED will be tuned on for long time. So it will be tuned on. So if I reset this refresh this watchdog timer after give the delay of 25 milliseconds means it will exceed the timeout for watchdog timer. Then it will reset the controller. So we will see this example here. So we will create a relay. Okay. So I will for we will make it as 18. Okay. Then we will call this refresh function. Oh. So now we will compile this and we will see whether there is error. So we have no errors and we will upload this. So now I will guys. So you can see this is our red LED which is connected with the pin of PD of 14. So now you can see we have resetted this, we have refreshed this watchdog timer before it reaching the timeout, which is our timeout. It is 20 milliseconds. So we will change this scenario. So we will make it as 25. So what is now I'm going to do is I'm not going to reset this watchdog timer till it is reaching the timeout. So we will upload this code now. Then we will reset this. Okay. So you can see our LED is blinking. Why it is blinking? Because our watchdog timer exceeds its timeout and it is resetting our controller itself. So while resetting the controller, it is reinitializing from int main. It will get into this function and it is getting tuned on. Again, it comes into this while and wait for 25 seconds. The watchdog timeout is 20 milliseconds. So this exceeds the watchdog timer. Then that means it was the loop is get stopped then. So it will automatically reset the reinitialize the controller totally. So this is why we are using this watchdog timer. Okay. So we will again this as 80. So if there is no error, if there is no error in the loop of proceedings, means if it will not tune off. LED is not tuned off. If this watchdog timer will be not reset the controller. If there is error, if there is error in execution of int main codes means, then there is some error and it is stopped in some of the lines means, then it will automatically exist. Watchdog timer will exit the timeout and it will automatically reset the reinitialize the controller. So this is used to refix our bugs without the user interface. Okay, interface. So we will again change this into 80 microseconds and we will see. So then we will reset this thing. So you can see now our LED is now our watchdog timer is not getting reset. So not it is no watchdog timer is not getting reset. Not the watchdog timer is not resetting the microcontroller, not reinitializing the microcontroller because the watchdog timer is refreshed within this time. Okay, so that means the loops are getting executed in the correct order. So that is why we are going into watchdog timer. Now what we are going to do is we will change this code into our project. So we will change this watchdog configuration as per our project requirements. Okay. So now we will come into the code. So now what we are going to do is we have already seen this. For our code, we are going to create a 10 seconds of watchdog timer. So if my temperature reading and moisture sensor reading, if my temperature sensor and moisture sensor doesn't give the values to the controller for more than 10 seconds means it's going to reinitialize all the controllers again so that I can get the readings perfectly. Okay. So it is just for the fault detection and correction of controls to avoid the faults. Okay. So this is a thing. So we are going to give this reload value as a 1249 and prescale value as a 256. So we will go to this. So what is our prescaler 256? So we have to give this, we have to left shift this logic 7 to this 0th bit so that it will be divided by 256. Okay. So we will. So what we have done now, we have given this prescale value, right? So we have left shifted this 7 to the 0th bit. Now it is 256. So what is the next thing we have to do? Is we have to give this value here 1249. So this is the value we have to give for reload because by this value is obtained by the formula. Okay. So next we are going to alter these codes. So you will get into this pump function. So we have created this refresh function, right? So we are going to call this refresh function and say this. Okay. So I'm going to call it here refresh. I'm going to call this so this is for checking my loop is working at the correct specified time. Okay. So this will eliminate our bugs or errors while operating. If this stuck inside this loop means, then it will reset the controller. If doesn't stuck means, it will get into this refresh function and reset our watchdog timer. Then it will reach our all value. Okay. at the final. So now we will upload this code and we will see this out. Okay. And we have called this code. So we are getting these values. Okay. So what is the next thing I'm going to do is I'll just so wait, I will show the outputs to you guys. So you can see our first pump is working, which is a supply of water. But the sprinkler is not working. Why it is not working? Because of the what is our temperature reading is showing it is a 25 degrees Celsius, right? So what is our temperature we have mentioned here? So it is not more than the temperatures are temperature value is not more than 30 degree. So it is not our motor is not sprinkler motor is not working. So what next we will increase this. So now the motor is supply pump has been stopped. Now what we are going to do is we will increase this temperature value. Sorry, reduce this temperature sensor value. So we'll make it as 24. Okay. So now we will upload this code and we will see the output. So now the readings are getting readed and our moisture is 45%, right? So then it will not tune on our pump. So when this moisture is less than, then it will like I will show you this. So now our supply pump is tuned on. Okay. So you can see there is a bug in this. There is a bug arrived in this loop. So what happened here is our sprinkler motor didn't start up because our temperature is more than so our temperature is greater than 24 degree. So our sprinkler motor has to tune on, but it is does not tune on, so that our watchdog timer exceeds its limit and it is resetting our controller. So it is starting from the initial stage. So that only this LED is indicating that the watchdog timer is getting reset. Okay. So if we again the moisture sensor increase means all the pumps will be get stopped. So this is how the process will be. We will be doing for this smart agriculture system. Now we have completed the programs for a main controller, which is STM32, which we are going to place it in form. What is the only one step left here is we have to transfer these all these moisture sensor value, moisture percentage, temperature, humidity, water source, pump state, all these things to the ESP32, and ESP32 is going to send those data to the cloud. So we can see it in the PC and mobile, right? So this is the only step left. In our next session, we are going to send these data to our ESP32 using the LoRa, and ESP32 will receive those data. Okay, guys. So today's session is over. We will meet on the next session. Thank you.